This is Dr. Chunchu Rambabu, Professor, EC Department, Dr. MGR Education and Research Institute, Chennai. Today we are going to discuss about full wave rectifier.
Okay.
So in the last class, we have discussed about half-wave rectifier. In that we have found ripple factor value. There the ripple factor is more than 1, and based on that I told one of the drawbacks if the ripple factor is more. So today we are going to discuss about full wave rectifier. As I told you, rectifier means whether it is half-wave rectifier or full wave rectifier. Both are used for converting the AC signal into a pulsating DC signal. So that is the main function. So in this full wave rectifier, there are two diodes called D1 and D2. There is a transformer, primary and a there are two windings in this, primary winding and secondary winding. This secondary winding is divided into two equal parts with the help of this centered tap. This line is called the centered tap. This is called this point. So this point is called centered tap. So what this center tap does, it will divide the secondary winding into two equal parts, so that the output voltage which is generated by the secondary coil will have one voltage here, another voltage, but both will have the same value, but sign is different. One is the positive, another one will be the negative. Both will have opposite sign. Now, what is the main working operation in this? We'll see. In this also two conditions. First one is, if suppose, as you know that this is the AC input signal. So when you are applying the AC input signal at the primary coil, okay. So what will happen here? When the positive, this is the positive, okay. Positive half cycle. This is called positive half cycle. Means during the positive half cycle, what will happen in the circuit? Because the diode D1, this is the positive, this is the negative, and same thing here, positive and negative. So what will happen means, during positive half cycle, D1 will be on, okay. During negative half cycle, D1 will be on, D2 will be on, which means during the positive, this is the positive half cycle, during this positive half cycle, D1 is on and D2 will be off. During the negative cycle, D2 is on and D1 will be off. This how half-wave rectifier will generate the output signal in the form of DC. So if you see here in this diagram, this is your actual input AC signal. So first positive cycle, it generates some output voltage. Again next negative half cycle, it generates the again some output voltage. In both conditions, positive half cycle and negative half cycle, in both cases it generates the output. Whereas in half-wave rectifier, what happens? Only during the first half cycle, only you can generate the output. But during the negative half cycle, your output is 0. Okay, that is the main difference. Now we can see how we can calculate the average DC output value based on this. So we are saying there is a DC output. Okay, so based on this DC output, how we can find out the value? So as we know that average means VDC, that is your actual output. The condition is, we know that V input is equal to Vm sin omega t. This is the actual input signal which we are applying at the primary. Okay. So now your output is, what is happening between the 0 to 2 pi. It generates the, see here, Vm sin omega t. The interval will be 0 is less than or equals to omega t is less than or equals to pi. Okay, this is the condition. So now I am applying this condition here for finding the average DC output voltage. So VDC is equal 1 over pi. Why we have taken pi? In half wave rectifier we have taken 1 over 2 pi. But here we are taking 1 over pi. The reason is, if you see in half wave rectifier, your output will be like this, which means 0 to pi output is there, but pi to 2 pi the output is, there is no output, means during the negative half cycle there is no output. And again the next starts from 2 pi. So we have taken from 0 to 2 pi in half wave rectifier, but whereas here it is repeating for every pi. For every pi it is generating the output. So we are taking limits is 0 to pi V naught dWt. This is the formula. In this formula, what is the V naught is Vm sin omega t. So just substitute here instead of V naught, Vm sin omega t dWt. So integral formula we know that. So sin omega t means integration of sin omega t minus cos omega t. Intervals are 0 to pi. Here Vm is the constant we are taking out. Okay, so sin omega t will becomes minus cos omega t 0 to pi. So when you apply the limits 0 to pi in cos omega t, you will get VDC as 2 Vm by 2 Vm over pi. This is the VDC value. Same thing IDC. You know that VDC means, as per the Ohm's law, V is equal to IR. So same current also, instead of Vm, you will write Im, 2 Im over pi. This is the current value, this is the voltage value.